Okay, so we try to move to the next speaker, that is Eryuan Liang from the Tibetan Plateau. And at the moment we have a technical problem, but we try to connect.
So now it's okay. So everybody can see my slide or not? So thanks, Chair. So can I start now? I think something. Okay, so good afternoon.
Okay, so just a minute. I think you have the presentation as well, no?
Yeah, yes, sir.
Okay, so you can. Possiamo chiedere di condividere lo schermo? So you can.
I can start. Okay.
Okay, you're sharing. You're already sharing the screen. Okay, so.
Yes, I already shared. Yes, yes.
So yes, please. Thank you. So you can.
Okay. Thanks, Chair. So I might talk about the tree line. So in the Himalaya. So this is my talk. So why we research Himalaya tree line? So I have several slides showed here. So the right side, you see this tree line is in the Himalaya, is a bird tree line clearly. So why study tree line in the Himalaya? You see that Himalaya is the longest, almost continuous distribution of tree line. So it's a very unique area for tree line study. When we talk about the tree line in Himalaya, and you can see that in fact, 200 years ago, Humboldt, he already plotted this vegetation along the elevations, and it also has one of the highest tree lines in the Himalaya. And especially in last 30 years, and if you see the climate record from pyramid, and this is, it is warming significantly, and also drying. So the warming and the drying, it is typical characters in the South Himalaya. So, and this warming and the dry climate, we like to know what the tree grows at tree line. So normally talk about the tree line is that the tree grows at the tree line was limited by moisture. But in this case, we try to test that the tree growth limited by moisture. So this is, we got the several tree line site. We take the cross and from the birch trees along the Himalaya mountain. And we found that in fact, tree growth was limited by moisture. So this is not by temperature. Even temperature is negative. It's different with other region. And if you see in the last 200 years, the missing rain frequency also increased. So why missing rain? It means that the growth environment close to the limit for tree growth. So in the last 200 years, with the increasing frequency of missing rain and with the warming, so this means that much dry. So why it's here is we can get moisture signals from the tree line species, because when about 3,000 meters elevation and too high elevation again, you see that reduce precipitation. So when this is the reason why at high elevation tree can be limited by moisture. So this also show that, so this nature news also report our result. You see that drought threatening high latitude Himalayan forest. So we use all those species to reconstruct the moisture in last 400 years. So this is unique species we can do, but I don't like to show the detail of this content. And with given tree growth were limited by moisture, we like to know, so what to do for tree line in last 200 years. So tree line position will move up, down, up, or just stable. So this is our research is we use this meta-analysis about the tree line site in the North Hemisphere. So we can see that, and some tree line in the high latitudes is move much faster than low latitudes. So there's something we can get. But also we found that not only temperature, but also precipitation is the limit for the tree line shift. So we try to test this hypothesis in the Central Himalaya, in Nepal, and we take the plot from east to the west. And in the east part, the annual rainfall 3,000 meters, and to the west, in 600 to 800 millimeters. So big difference. We try to see what changes of tree line along this precipitation trend. And we found that tree line movement was limited by precipitation, especially in spring season, but also by annual temperature. But precipitation is control more than temperature to explain tree line shift. So it means that not only temperature, but the precipitation also works on the influence on the tree line shift. So we like to test. So why precipitation have influence on the tree line movement? And we found that along this, with reduced precipitation, you see that the seedling always clustered together. So this class also influence on the tree line shift. So this means that precipitation drive tree line shift by causing seedling clustering. So this may be only one reason, maybe also others in behind, but this is our primary result. So I'll move a little fast, and we talk about not only tree line, but in the Himalaya also the shrub line. You see this juniper shrub line. For example, this side shrub line can about around 5,300 meters is juniper shrub, and the right side is one video. I think I'm not sure I can. So you can feel in harsh environment at the shrub line. So there's very strong wind. In fact, it is also very dry. Okay, I move on down. And this is one species, single juniper shrub. And you see that it's not small. So they cover this area around 20 square meters. It is one tree just lying on the ground. And if you see the temperature, annual temperature and the soil temperature, you will see that the soil temperature is much higher than air temperature. This is the reason why this shrub always lie on the ground. So there are many things. We also some work ongoing, but this is something new research. And we also found that even at this high elevation tree line, but some trees more than 400 years old. And we also test what's the limitation for this growth of this shrub, but the model is precipitation is more important, so not others. And we also test, so what's the changes of recruitment in last 400 years. We found that in 1920 or 30s, their peak regeneration, then in last almost 100 years, always reduce recruitment. So we see that why this recruits, because that this past the climate of terms, because with warming climate, this is then warming make this more water stress. So this reason why have reduced recruitment. But we also other with research we are working on in South Himalaya, but I do not check. And there's another case study in the South Himalaya. We also found that you see the same things, reduce recruitment in last several decades. So this is due to the warming. So the warming is make risk for this high elevation shrubland, but not only from this our plot study. So we also landscape image also show reduce of vegetation greenness in several valleys. So there doesn't matter our plot, but also this landscape image also shows same story about the reduced activity of shrub. So this the last start the for key message. So we show that the change in tree line and shrub line in response to global warming in Central Himalaya. So tree growth at upper tree line, tip line is limited by the pre-monsoon moisture, not limited by temperature. So precipitation and biotic factors immediate response over tree line shift to global warming. So past climate optimum. So recruitment is declining as the world highs per shrub line. So thanks so much. This is my last slide.
Thank you. Thank you.